Hello, in this video I'm going to talk about logarithmic function, which is defined as a function of log x of base a. Alright, we talk about basic one. So where the value of a must be a number greater than 1. Alright, means it's an integer number that must be positive and greater than 1, and x to be also a number greater than 0, right? As you know that for log is only defined for positive number, which also should not be 0, and the value inside the log must be always positive, right? This is the characteristic of logarithmic function. So as you see that this type of graph of logarithm, where the graph for logarithm does not exist on the negative axis here. It does not exist on the negative axis of value of x. Means that the negative x value here, the negative value for the x, so means that if this is x, then the x must be greater than 0. So means that x greater than 0 means x equals to 0. Actually, x equals to 0 represent the y-axis. So the graph will be in this shape. So then it will intercept the x-axis. So how to find the x-intercept, right? So the x-intercept. So for x-intercept, the y will be 0, right? Y will be 0 means that your y equals to log x to the base a, and where your the graph intersect the y-axis, the x have to be the y have to be 0, right? So means that intersect the x-axis, so the y value have to be 0. So x, so if you're solving this, a to the power of 0, which is 1, right? Which give you 1. So this is the shape of the graph for log x to the base a. So alright, it's different when you have fx equals to log negative x. Yeah, and you know that I have tell you that a must be a number greater than 1, right? I was setting in my video, I was setting for exponential function, the base is always greater than 1. So it's easy to sketching the graph without consider the base. So now a more than 1. So the negative x also must be greater than 0. Yes, it shouldn't be negative in the value inside the log, right? It shouldn't be negative, but because this is unknown, x is an unknown, so this unknown must be the value of x here must be negative, right? Because negative and negative will become positive, right? Or we said that negative x must be a number greater than 0. Then if we solve for this inequality, we have getting x less than 0. Means x must be a negative number, so that in order for this to be positive. So the graph will be, you see the graph. The graph now will not exist on the positive x-axis. Why? Because when the x is positive, this one will be negative, right? So it won't exist. So means it will be follow this domain here, x less than 0. So means this will be the graph, right? So if you find for the x-intercept, y will be 0, right? So means that the log negative x to the base a will be equals to 0. So negative x equals to a to the power of 0, which is equals to 1, and x equals to negative 1, which the intercept will be at here, negative 1. And this will be the asymptote, vertical asymptote, where the curve forever approaching this axis but never touching this axis. That's the reason why, because you cannot have x equals to 0. You cannot have x equals to 0. Log is not defined when the value here is 0, right? Or negative, right? So this will be the two basic graph. So same thing also is like the graph for exponential function. I just asking you what happened when you put a negative here, right? If you put a negative here, it won't affect the value inside here, but it will affect the graph. Means that supposed to be a positive, supposed to be a positive value. Above the x-axis means the y value is positive. Below the x-axis, this is a negative value, right? Negative value, the y. So once you put a negative, the positive part will become the negative part, and the negative part will become the positive part. Or easily, we just say it's reflected about the x-axis here. Supposed to be this way, it will going down, it reflect about the x-axis. So if you see that, what's the difference between these two? You will see that for this above the curve here, if reflected, become below the x-axis. And for the one that below the x-axis, when it reflected, it will become above the x-axis, right? So, all right, it's the same thing. And for fx equals to negative log negative x to the base a, will be the same concept apply here, the same technique apply here, where the curve you have x and y, so the curve will be supposed to be the positive one will become the negative, and the negative one become the positive. So if reflected, and they will still the same, intersect at -1. So out of all these graph here, the 4 basic graph here, so the domain is the one very important for this. The domain here, domain refer to x, right? So your domain for f will be starting from not 1, it's from 0 up to, or we can say that x must be greater than 0, right? X greater than 0. So you see that the graph will be start from 0, but it cannot include 0, move up to infinity, means from 0 up to infinity, because x must greater than 0. And for the range, you see that the graph, everywhere there is a graph along the y-axis. If you keep drawing, there is a graph for any value of y. So it will be -infinity to infinity. Or we said that y can be any value. Alright, can be any value. So same thing here. The domain will be less than 0, because negative x must be greater than 0. So less than 0 means -infinity up to 0. And the range is still the same thing, always -infinity to infinity, right? If you compare to the graph for exponential function, this will be reversed, right? Will be reversed, where the domain always -infinity to infinity, but the range is something that you want to look at it, right? For this case, this is a logarithmic function, so the domains is something that you need to look at it, and the range is always -infinity to infinity. So same thing here also, the domain will be still depend on the inside one, the x more than 0, so will be 0 up to infinity, and the range will be still the same, -infinity up to infinity. And this one also, the range will be -infinity to infinity, but the domain will be x less than 0, right? So which is -infinity up to 0, right? So that's all for this 4 basic. We move on to a second part of this logarithmic function.